Good day to everyone. So in the last video, I have explained how to plot this figure with the GNS script, the corresponding GNS script, and line by line I have explained the instructions we have used in the plot to plot this figure. So next I'm going to use another script file to plot the different figure where I have used the palette I have used with the palette color I have used. That means the third axis is actually mentioned by the different colors. I mean with a black and white combination. I also used the three different data files to plot this command. That means that to plot this figure. So the rest of the set terminal and everything is actually the similar like whatever I have explained in the last video. So I just not going into that. I'm just going into the details of the how to plot the palette plot with the different figure files and how to customize the palette colors and the palette style and everything. I'm going to explain in this video. So this the set label and everything you have already seen in the last video. So here I'm starting with this the set CB ticks. That means here I have used the data file that is the energy underscore delay dot dat, which is actually having the three columns 1, 2, and 3. The first column I have the values of the x-axis, and the second column I have the values for the y-axis, and the third column, the third column I have the dE by the value of the dE by dt, the rate of change of energy. So I have plotted in the range of 0 to minus 0.12. So I want to show this the rate of change of energy in terms of the palette, in terms of the shading of colors. Either you can give it as the full color or with the grayscale. So I prefer with the grayscale here so that I can the picture will be somewhat clear with the grayscale. So I have used the grayscale here. So the CB ticks that means this is called the CB ticks scale plot. So I can just rearrange. Defaultly it is actually showing the size of some different size, but I want to make it as a thin as well as the crisp. The equivalent with the corresponding y-axis, so that I can use the CB ticks no angle limit of the corresponding value, so that it is actually originally it is actually plotted here, plotted with a different size, but I want to make it as a thin as well as it should be near with the corresponding y-axis. So I just rearrange the position of the CB ticks with the ticks values with the 0.04. So every 0.04 it actually showing the number. Okay, so 0, minus 0.04, minus 0.08, and minus 0. So every 0.04 interval it's writing the ticks level, as the tick size, the label. So I just mentioned it as a 0.04 as my CB ticks, and the CB range is actually starting from the 0 to minus 0.1, because I have the data in the range of 0 to minus 0.12. So that I am just writing in the CB range as starting value and the ending value. With a suppose if you want to if we default it to show you the different ticks level both in the both sides of the ticks level, but I want to make it as a single line with I don't want this mirror with the reverse effect. So I just clean it like this, so that I have used the no reverse command to just avoiding the other the axis pointer. And I want to, you can use this, you can make this the color box as a horizontal one or vertical one. So I prefer the vertical ones. I have used the vertical user, and as I already told you that this is actually plotted here. This is actually usually defaulted show here. So I just want to make it move it to here, as well as I want to make adjust the thickness of this color box with the user defined color, thickness. So I have used the origin. I have changed the origin value as 1.2. That means the x-axis as well as y-axis, and the size is also I just changed it with the my convenience. And so actually, suppose if you want to replotting different plots, I want to make this CBT as in the front side, in the front layer. So I just use the command front. That means Suppose if you're having the background, suppose you are having the picture in the background, so this one is actually highlighted with the first layer. Okay, so I just use the command front, and the CB label, the word, however how we are actually writing the X label and Y label, you can also write the CB label as dE by dt, and usually it actually mentioned as a zero, mentioned in plotted with this like this. That means dE divided by dt. This is how it actually write with write the value. With the defaultly it is actually writing the like this, but I want to rotate this with degree. Just I want to rotate it, so that you can just use the rotate with the angle, and that is the corresponding X value and Y value which you can give it, so that it will actually plot the, just rotate the whatever the axis you are, whatever the font you want to use, when the word you are using, it will rotate with the corresponding degree. Okay, here I have used a 0, so that there is no change in the rotation. Means there is no change in the CB label, and it actually given it. I will also show you that how this rotated figures will look like in the different other demonstrated other figure file. Similarly, I have given the X ticks and Y ticks, where the X ticks, the ticks value is actually starting, the ticks interval should be in the 0.25, 2.5 for the X axis and the 2 for the Y axis. I have mentioned it here, and I already CB takes I don't have a the Z axis here. I just mentioned, this is not required, so that I can just mention the note Z takes, and I already told you that the size, suppose if you want to make it a square file or as a rectangle, then you can mention it with here. Suppose if you are keeping the ratio for the X axis and Y axis, you can mention with the numbers, so you can make it the different size figures. And this is set palette defined is actually mentioning the background grayscale. So this grayscale is actually this palette is actually divided into 6 different parts. There is the first part, second part, third, fourth, fifth, and sixth. So each different parts having the different shades. So I have mentioned the part 0 to 1 is actually having the shade of full black to some grayscale, which is actually mentioned by the hexadecimal CD. So which is actually used here. That means from 0 to 1 mentioned with the different shades. Okay. Similarly, from 1 to 2, I actually use the different shades. Which I have just customized my the palette with my user defined shade. So I have used the part of the 1 to 2 is actually having the shades from this value to this value. Similarly, the second having the value of this one, and finally the fifth is actually starting from the value of 2b and with the full white. So whatever is actually the data which is having the value of 0, which is actually plotted with the whatever the value which is actually having the value of 0.12 minus 0.12, which is actually represented by the white color, and the values which is near to the 0, which is actually represented by the black color. Okay, so this is how this the palette is actually defined, so that the background color, this background data will actually showing that this different layers of the different colors with the different layers. So these different layers is actually mentioned by the corresponding layer which I am using. Okay, so this is not actually a smoothly varying function. I am actually customized it with my own defined function. So you can also do that in the Gnuplot itself. Okay. Okay. So similarly, I have used the 3 different plots. 1, 2, 3, 4. I have used the 5 different data files in the single file. So you can just mention the x-axis and the range of the X range and Y range. That is starting from -3 to +3 is X range, and Y range is actually starting from -2 to 3.0. And this energy delay.dat is the data file which is actually having this value, having the value of this data. That means the background data. And one more thing is I have used the every 2.2. That means I am not plotting all the data which is in the data file. That means I actually skipping the every 2. Skipping the different 2 rows to plot the data, because of the just want to compress the avoiding the size of the figure, because even though it is actually showing the smooth line, so I'm actually omitting the different data which is in between the different data lines. I have skipped the different values. You can also skip this with the command EV, that means every 2:2, that means x axis as well as y axis, using the 1:2:3, that means the x axis, y axis, as well as the third column which I have used is represented by the color, which is also mentioned, which is also given in the third column. Okay, so I am actually plotting the three columns in a two-dimensional plot. Okay, so the first dimension I am showing the first column, second dimension I am showing the second column, and the third dimension is actually represented by the color. Okay, so this color is actually given defined by the palette, and this each and every dot is actually mentioned by the point, the size point type of 7 and the point size of 0.3. Suppose if you change the point size, then you can easily see the points here, but I have used a very small small points. You can be able to see the points here because of the huge data file with having the huge data. Similarly, I can plot this red color the lines, and as well as the white color lines with this two data files, and the filled circles, which is already having the values of x value and y value, is already mentioned in the this data file ic1.dat, ic2.dat, which is actually showing the initial conditions of the corresponding trajectory. Okay, so that I can just combine the five different data files in the single figure. So we can do that also. Okay, fine. So in the next figure, so in the previous figure I used the monochrome, the grayscale shading, and the palette in the grayscale. But in this figure, I have used the color scale. Also, I have changed the CB ticks, means the color box size, as well as the where I have fixed it. So initial, and also this is a three-dimensional figure. So the previously whatever we have seen in the previous is actually two-dimensional figure. That means I have only the data for the x and y, and you can represent the third value as you can just focus you have projected the three-dimensional data in a two-dimensional figure. But here in this data, I have shown the three-dimensional data in the three-dimensional axis, the x-axis, y-axis, as well as z-axis. So here also this z-axis is actually represented by the colors, but still I have also mentioned the third axis as z-axis as the third axis here. Okay, but just for the visual representation, I just again converted this z-axis with the colors, with the palette color, so that I can see the difference between each and every point represented here, just for the visualization purpose. Okay, so whatever the first initially the border and the set style, the laces, different labels, whatever the labels, because here I have used the labels as this data is actually having the very large data file, that is actually starting from the minus 4 lakhs to some around 21 lakhs something, because I have a different huge data here. So I just simply plot it as a 0 and 1, 2 with the power of 10 power 6. I have written like this just for the clarity purpose, and I have also given the CB range and everything in the same range. The different range, whatever the range I required, and you can see here that I don't want to plot the CB label. I don't want the CB label here. I just manually write the label here, so that I don't like this. Here I have used the CB label as I already mentioned here, but here I don't want the CB label, so I manually write the label with the corresponding label. So I just omitted I just unset the CB label with the command unset. Similarly, ticks also I have mentioned with the manually I have mentioned the Z ticks, so that the CB ticks is not required here for my figure, so that I have unset again with the CB ticks. Okay. Again, the tick level is actually starting with the 0. That means the Z ticks actually starting with the 0, so that I can clearly show the color variation in the figure. Okay. So this is the again the color box, where I have actually the color box is actually vertical, as well as I have used the origin. That means I have just moved the color box with the different user defined values. Similarly, I have used the same color box vertical with the origin is actually usually this is actually plotted here. Maybe it is actually shown here with a different thickness, but I want to make it with in the z-axis so that this will actually easily represent the x-axis as well as the color combination, so that I have moved the color box from here to here with a different thickness and the size. So size and the thickness I have is changed with the command set color box. The vertical, I have used the vertical color box, and I have used the defined origin and the size I have mentioned here. So this is the x sticks and y sticks, all the x sticks, y sticks, and z sticks, everything I have manually written as. So 0 will be taken as 0, and the 10 lakhs will be written as 1, 20 lakhs will be written as 2, so that I can write it as a 2 into 10 power 6. Okay, so that I can write it here. So I just forgot to write one more thing that I just mentioned, the label. So if you want to make it as a, you want to write it as a x of t plus tau and with a modified angle. When I just rotated this angle, actually it actually write it as like in this direction. Similarly, this is actually written the similar like. So I just want to make it this rotation. This rotation is also possible here. In the mentioning the label, I have rotated the rotate by this angle. Okay, so this x of t plus tau, the equivalent value for the tau is 164. So x of t plus tau is actually having the position of this x-axis, x value and y value, and this value is actually rotated by 65 degrees from this horizontal line. This 65, so that this is actually showing the corresponding the rotated value here. Similarly, I have rotated this value by 90 degrees from the original value with the, so that I can put it as a 0 point, with the angle of 90 degrees. So it actually rotated with the 90 degree. So you can use this rotating the whatever the labels by using the command rotate. Okay, and similarly the size. And also, suppose if you are using the 3D command, 3D diagram, suppose if you want to rotate this, means you have to show the particular projection, then you can easily fix the view with the corresponding values. So this values is actually mentioned the x-axis, y-axis, as well as the corresponding orientation, so that whatever the orientation you require, you can just fix it here, just trial and error method, or you can just plot this figure as a Gnuplot environment, so that you can just moving the cursor or moving the mouse pointer, you can just rotate the figure based on the rotation and the projection. You can calculate this values, see the values and give it in the script file. I will demonstrate this how to rotate the three-dimensional figure in the online class. Okay. And similarly, I have defined my own plot. Again, the set plot defined as 0 is mentioned as black, 2 is mentioned as blue, 4 is mentioning the green, and 6 is mentioning yellow, 7 is orange, 10 is red. So I can actually separating this palette as 6 different parts again. So the 0 is actually mentioning the value of 0 is mentioning the black color. So instead of using the hexadecimal codes, I am actually writing using the primary colors, the different color values. So you can use the different set of color values in the Gnuplot. But it's not, you cannot able to use the most of all the colors, but like the hexa code. Suppose if you are giving the combination of the RGB, you can create millions of colors, but here you can have some set of colors, the named colors which are already available in the Gnuplot, like blue, black, brown, and magenta. You can use that color. So I want to just mentioning that different values is actually having them in different different colors, so that it is actually automatically convert this gradient from 0 to 2. It is actually the conversion is happen from black to blue, then blue to green, then green to yellow, yellow to orange, orange to red. This actually the gradient, this change of gradients will be happening smoothly, even though you are actually mentioning it as a different colors. For example, you can see that there is a transition from green to red with a smooth transition from green to red. Is you can see the smooth transition. So you can customize whatever the values with the colors you require. You can change it according to your use with the command set palette defined. So you can customize, you can the user defined palette, you can use it, and then the data file whatever the have it with the I can plot it with the splot. That means I have used 3D plot here. Suppose if you want to plot the two-dimensional plot, you can use the command set plot, and for the plotting the three-dimensional plots, you have to use the command set splot. Okay, splot the file name dot dash with the regular the lines or block. I have used the palette here, so I have used the point palette. This palette is actually plotting the gradient. Okay, the point palette. This point size is actually in the point type is 7. That means the closed circle, and point size is taken as a 0.9. So according to my figure requirement. So you can also modify the point size. Okay, so this script file will actually generate the this figure with the palette defined. So I have a couple of other figures the first figure, the other figure, the other script file is actually plotting the data file with the two different y-axis. So initially in all the other values we have one x-axis, one y-axis, and one z-axis, or one x-axis or y-axis. But here in this figure, I have used the single x-axis, but I'm showing the data, two different data in the two different y-axis. So this y-axis is actually showing the purple color, and this y-axis is actually showing the different axis range, but with the different y-axis. This is also you can do with the Gnuplot. So you can completely customize your figures. Suppose if you know the exact command and how to use the Gnuplot in the corresponding the manipulation of your figures. Okay, suppose if you want to put the second y label, you have to use the y2. That means y2 command. X1, you can use the x1, y1 is for the first, means the first as usual axis. Suppose the second y axis is actually mentioned by the axis x1 comma x1 y2. So this x1 y2 will actually show telling that you are actually using the second y axis. So you can see here that in the previous figures, suppose if you note it down. So the whatever the axis which we are using here, which will be exactly mirrored in the opposite direction also. But here in this figure, you can see that this the first x-axis in the different range, and second y-axis is also in the different y range, which you can mention it here, the y label and y range, the y ticks and different y range, y ticks and y range, you can mention it with the different ranges, where the first y axis is actually started from 0 to 6, whereas the second y axis is actually started from the value 0 to 0.25. Okay, so the each different data files plotted in the figure showing the different y range. Okay, even though the x range is similar, the y range is actually different for the different. So I just want to the clarity purpose, I am actually using the figure and the figure axis color at the same, so that you can easily see we can easily identify that this data is corresponding to the this y axis, and this corresponding y data is actually mentioned equivalent to the other y axis. That I can just visually represent in the each different in colors. You can easily identify the figure. Okay. So here also I have used the two different data plots, three different data plots actually. So this data, the purple data and the orange data, the other one is a fit. This fit is this fit, the corresponding fit I have already have it as a data file. So that I used the three different data and plotted the data here. So you can see that I have plotted the same data twice. That is for the just for the enhancing the data points with the closed circle with the open circle. So if we want to plot like this, I have used the point as this point as a different size, and the open circle is actually point with a different the 0.6. That means it's actually close to open circle. 0.7 is actually the closed circle. So that with the different point sizes, that is the point size is 2.5. so that I can mention this as just I can enhance the point size, the points with the different styles. So I can just using with it for this purpose. I have replotted the same data twice in the two plots. So here you can see that this triangle is actually having the filled one, and it is in the border. It is actually having the different color, so that I can just enhance the points with the different colors. Okay. So in this all this figures we have seen is the normal axis we have used. Suppose if you want to make it as a log plot, that means you have to want to make it as a log axis. The axis is the log values. You can use this with the set log scale. Suppose if you want to make the x-axis as a normal axis and y-axis as a log scale, then you can just mention as a log scale y here, the command y. That means set log scale y, so that this file is actually converting the figure file into partially the log file, the partially log file. That means the x-axis in the regular format and y-axis will be in the log format. Suppose if you want to do it opposite, that means the x-axis should be in the log value, whereas the y-axis will be in the normal value. Then you can put the set log scale as x, so that this the x-axis is printed with the log scale. Okay, so I want both the x-axis and y-axis to be in the log scale, so I can just simply write it as a set log scale. And I have plotted the different data files, and this different data files I have already told you that set the key, the first figure I have used the set key. That means suppose whatever the data I am plotting here, that should be written with the title. So if you want to do that, then you have to set the key. Otherwise, you can just unset the key or set no key. You can use. Suppose if you are using set key, then whatever the data you are writing, that will be show with the whatever the line or a point types you are using, which will be showing in the right side corner. But also you can customize this with any corner, whether it's the left side or right side or center, wherever you want to keep this key. Then you can do that with the x-axis and y-axis. So nothing new in this figure other than the plotting the log scales with the log scale. Okay, as usual, you can have the size and whatever the plot you have used. As I already told you that you can also use the functions in the Gnuplot, so that I can just use the power law scaling function here with different exponents and the amplitude, the power. So you can just directly mention it in the scale, and then you can plot the fit. Okay, so I can use the title to write the corresponding title I equal to 30, which is actually represented here with the corresponding key values, the position of the x-axis and y-axis. Similarly, you can do that for the other data also, so that the circle is actually representing the I equal to 30, and this filled triangle, square, which is actually representing the color with a different color, is actually mentioned for the data I is equal to 40, and the triangle, filled triangle with the blue color, showing the data for the I is equal to 50. So this is, you can do that, and the fit is actually mentioned by the red color continuous line. So we can just give this information in the figure with this kind of script. So suppose if you want to edit the script according to your views, so you can use different commands and different styles. You can use it here. Okay, so these are all just a basic plotting commands. Suppose if you want to make it as a more advanced figures, or if you want to customize your figures according to your needs, then you can use the commands. These commands, all the script commands, everything is already available in the Gnuplot website on the demos, or you have the dedicated Gnuplot book is already available. You can just refer the book, and then you can write the different commands here required in the plot. Okay, so I stop here, and I will demonstrate how to plot these figures or convert this figure into the different format in the online class. Thank you.